right, in this section, it's going to introduce a couple of new topics, but it's also going to be a nice review of topics that we've covered already because we're going to be talking about these linear functions. So linear are lines, our y equals mx plus b, and our functions are what we looked at a few videos ago in 3.1. But we're going to be applying them. So almost all of these are going to have business applications. They'll be related to business. So on these, our first three are a review, the how we calculate the revenue, the cost, and the profit. That hasn't changed, so those are still the exact same. But then we're going to add three new ideas. So the average cost, the marginal cost, and the marginal revenue. So average is another way of we say the mean a lot of times. So we think about mean, median, and mode. So to find the average, I add up everything and I would divide by the number of items. For instance, to figure out the class average for an exam, I would add up all of our exam scores and I would divide by the number of students in the class. And we see the same thing with cost. We're going to take our total cost, so we're going to add up our cost we had before, and then we're going to divide by the number of items. So we're just adding one more step to that cost function. Same cost function where we add up the cost and then we're going to divide. And then we've got our marginal cost and our marginal revenue. Marginal is always going to tell us we're asking for one more thing. So whether it's the cost or the revenue, if it's marginal, it will be what would the next item cost us. And so in our lines, which is what we're dealing with because we're in linear, so with lines, this marginal is going to be the slope. Because remember in our equation, y equals mx plus b, m is our slope. And so every time we increase the number of items, our x, I get more slope. If I were to plug in 1, maybe that's a 5x. I'll plug in 1, I would get 5. I plug in 2, I would get 10. It keeps increasing that slope. Every time I plug in an x, it's going to affect the slope. So that's our marginal on there. It's going to refer to our slope. All right, so let's get looking at these problems now that we had a kind of a rundown of the different topics at the top. So for this first one, we want to find the cost function. So that's from way up here, this cost function. So C of x is going to be equal to the fixed cost. So that's going to be the $95. Plus the variable cost, that's the cost that goes with the variable. So that changes depending on how many miles we go. So 95 plus 8x. And you could change the order of that and you could have 8x plus 95 and that would work just fine. Now 2 here is going to bring in the new concept of average cost for 200 items. So if we remember back up here to our average cost, I'm going to have to figure out my total cost for 200 and divide it by that same x. So in this case, x is 200. So it would be 27 times 200 less 600. Just plug in 200 in for x. And then I'm also going to have to divide by 200. That's what makes it an average cost, is dividing by that x. So let's see, typing in that numerator in my calculator is going to give me 6,000. 6,000 divided by 200 is 30. So the average cost is $30 per item. Each item costs on average $30. All right, example 3, different one. Each one of these is a little different. We've got a car here. And we're told how much it's worth at the beginning and then how much it's worth in 4 years. And we're asked to find a linear depreciation. Now that is a really fancy word for something that you already know how to do. You don't have to learn something new. If I'm asking for a line, then I'm asking for y equals mx plus b. Doesn't matter if it says depreciation or not. Depreciation just really means I'm going to have a negative slope. The car is losing value. And that's true for cars until they become vintage. And they start gaining some value, but for the most part, they're losing value. So to write an equation of a line, I need to find m. So skills that we already did before, just we're now doing them in terms of just business applications instead of just giving you 2 points. So I do need to find my 2 points. The car is new, so that's going to be at time 0 whenever we bought the car. It's worth that $25,035. And then in 4 years, it's worth $14,115. And do remember that the years are going to go in the X spot because they are independent. And I am going to, I'm going to plug in my values. I'm going to plug in the Y's over the X's. And I should get a negative number for my answer because it did say depreciation. So my slope is here. And remember that little trick that if we are given a 0, that's going to be the y-intercept, b. Now if I didn't have a 0, if I wasn't given that 0 one, I would have to solve for b. But I'm going to take the shortcut on this one since I was given it, and also because I'm out of space. Oops. So that's the answer for part A, my equation. Y equals mx plus b. We're supposed to use this to find the value of the car in 7 years. So I'm going to plug in 7 for x. And I'm just going to type that in my calculator. So the value of the car is $5,925.